Statement that y is directly proportional to x means what? Well, direct proportion means basically if y gets twice as big, or if x gets twice as big, y gets twice as big. If x is half as big, y is half as big. Directly proportional means that these things grow in proportion. That means, among other things, that y over x equals constant. So y is some constant multiple of x. If we were to draw a graph of y versus x, this would mean that y is a constant times x. When x equals 0, that would make y equal 0. And this constant means that this graph is going to have a constant slope. So this is a graph of the situation y is proportional to x. Now, rate of temperature change is directly proportional to what we're going to call temperature difference. Let me explain temperature difference a little bit. Right now, in this room, the temperature is about 72 degrees Fahrenheit. If I was to set an object, if I was to heat this domino up and set it down here and let it cool off, it would cool at a rate that's determined by how much the temperature of the domino differs from the temperature of its surroundings. So if the domino is at, let's say, 82 degrees, then it's 10 degrees above the room temperature, and it'll cool at one rate. If it was at 92 degrees, it would be 20 degrees above room temperature, and it would cool at twice the rate, assuming that the rate of change is directly proportional to temperature difference. So, first of all, temperature difference is temperature of the object minus the temperature of the room. Now this could be ambient temperature or temperature of the surroundings. We're going to say temperature of the room. So there's the motivation for the idea of temperature difference. Now if the rate of temperature change is directly proportional to this means that, well, what's the rate of temperature change? That's the rate of change of big T temperature with respect to little t time. And that, if it's directly proportional to temperature difference, has to equal some constant times the temperature difference. What's the temperature difference? That's T minus T room. Now traditionally we'll let this constant be represented by the letter K. So we're going to say that this is the case if for some constant number K we have this equation, which we see is a differential equation. It's first order linear and it's non-homogeneous. So this is a perfectly good equation.